Alright, this is going to be lecture 6.4, salts and metals. We're going to look at, again, some properties, physical and chemical properties of salts, and then also look at metals and compare the two. The things that you need to know for this is the difference between an ionic and a metallic bonding. Even though it says covalent bonding here, we're not going to talk about that yet. So we're going to stress the ionic and the metallic bonding. Alright, so a lot of this is going to be review. An ionic compound is made up of a metal and a non-metal, and that's going to produce the salt. Okay, it can be made up of a metal and a oxide and create a metal oxide. The cation is always going to be attracted to the anion, and that where do we get that attraction between the positive and the negative, the cation and the anion? We get that from a transferring of electrons. And where does the transferring electrons come from? It comes from the cation losing the electron to satisfy its octet rule, and the anion gaining the electron to satisfy the octet rule. So again, here we have sodium with one valence electron. It's going to transfer its one valence electron to over here. Now the sodium drops down to the next lower energy level, which has 8. The chlorine, since it has gained an electron, now has 8. But since they've lost and gained electrons, they have a positive and negative charge, and that attraction is the ionic bond. The electrostatic attraction is the ionic bond. Some properties of ionic compounds. They are crystal structure at room temperature. They will dissolve in water, basically breaking back down into the ions, sodium ion and chlorine ion. They will conduct electricity when they're melted, molten, or dissolved in water. They will not conduct electricity when they are solid. Again, they have a no overall net charge. They have a high melting and boiling point, and they are hard and brittle. And we're going to look at each one of these separately. So let's look at the physical structure. Again, the formula unit or the unit cell is going to be the sodium chloride, and this is the main unit that builds that crystal lattice structure. This is the formula that we would write. However, in nature, it exists as what's called a crystal lattice. And this is just a bunch of repeating of the unit cells. Okay, so here's our sodium and here's our chlorine, but you notice it's a repeating pattern. All right, and there's the salt structure there in the picture, and that shows it more again. And it's always salt or sodium chlorine, sodium chlorine, sodium chlorine. This is the crystal lattice structure. This right here is the crystal lattice. Alright, and remember, to break this apart, we need to break each one of these bonds. All these bonds we have to break. So it takes a lot of energy, a lot of bonds. It takes a lot of energy to break all those bonds. And that's why these things have such high melting and boiling point temperatures. They dissolve in water. So here's a picture, a diagram. Here is our solid salt here. Here's our water. And what's happening in this barrier right here is basically the water molecules are attacking the crystal lattice structure, and they're basically ripping the salt, the sodium, and the chlorine apart and keeping them from bonding back together. They're blocking that positive cation attraction to the negative anion attraction. So, and if you notice here, here's the positive sodium, and the oxygen is negative. Each oxygen is negative. Here is the negative chlorine, and each hydrogen from the water is positive. So you notice that the positive hydrogens are attracted to the negative chlorines, and the negative oxygens are attracted to the positive sodiums. Okay, so again, these guys are keeping these ions from reattaching. If you evaporate the water, the sodium and chlorine can get back together and reform the crystal lattice structure. Okay, and again, this shows it a little bit a different diagram, but just notice that the opposites, how it's basically creating a hydration bubble around each of the sodium and chlorine, and that again is keeping these things from attracting and reforming the salt. Right, so that's dissolving in water. When they dissolve, so for things to conduct electricity, you need ions. You need free ions to move around. Okay, in regular water, there are no free ions. It's just water, H2O, H2O, H2O. Okay, there's no free ions. In solid ionic structure in the crystal lattice, there are no free ions. They're all bonded together. Okay, they're all bonded together in here. But when you dissolve the things, you have free ions, free sodium and free chlorine, and that is what will conduct electricity. So in solution, the positive and the negative ions move and conduct the current. So you will see this have a current electricity. Okay, if you have a lot of ions, you will create a bright light. If you have a low number of ions, you will create a low light. If you have no ions, no free ions, like in these situations here, you will have no light. Okay, so ionic compounds, when dissolved in water, will conduct electricity, but they have to be dissolved in or melted. There is a no overall net charge. Compounds are neutral, and again, it's because there's an equal number of sodium and chlorine in these crystal lattices structures, so they all cancel out. And again, this just shows you why the cation will lose the electron, the anion will gain the electron, and we get our positive and our negative. Okay, this is the formula unit, or the unit cell. This is the main building block, but it actually exists as this crystal lattice structure. High melting and high boiling points because of all the bonds. Think about that crystal lattice structure, all the bonds, lots of bonds in that crystal lattice structure. It takes a lot of energy to break the bonds, so the more bonds, the more energy that melt or boil. So here's sodium chloride, 801 degrees to melt salt crystals. So, and our Bunsen burners will not actually get this hot. They are hard and brittle. So even though they are hard because of this alternating pattern of a sodium positive and a chlorine negative, they are hard in the structure. But if you add a little bit of stress and push those layers so that the chlorine atoms are next to each other and the sodium ions are next to each other, then this will repel. These guys will repel each other, and that will make it brittle. Just comparing, let's look more specifically at metals. Metallic bonds form between like metal ions, whereas ionic compounds between metals and nonmetals. They are both arranged into crystals. They both have high melting and boiling points. In the metals, the valence electrons they're not attached to a specific orbital. They move freely throughout the crystal, so they're kind of wandering around in that crystal. However, in salts, the valence electrons stay in the orbitals. They have already been transferred to form cations and anions, but they stay in those orbitals once they're there. The metals, they move free. Because they move free, they conduct electricity as solids, and because of these free moving electrons. And in salts, the only time you have to have free ions, and the only time you have free ions is when they're molten or dissolved in water. Okay, metals are malleable and ductile. And salts are brittle, but they're also hard. One thing I would also say that metals will conduct heat. Metals will conduct heat and electricity. All right, if you have any questions on this, bring them to class and we can answer them then.